Right, welcome. Now we are doing parallel lines. So I want you to study these two graphs here. You have the two graphs here. Y is equal to 2x minus 2x plus 2, y is equal to 2x plus 2, which we can also call line 1. Then we have line 2, y is equal to 2x minus 1. So there's two graphs. If you study them and if you look at them, well, if you want, you can put your protractor and measure this angle here and measure this angle here. You will find the corresponding angles are equal. Therefore, these lines are parallel. That would be proving that the lines are parallel using geometry. So now, these are arrowheads showing the lines continue. Now I am saying these two lines are parallel. And I am saying you can put your protractor here, find the corresponding angles are equal, therefore these lines are parallel. Alright, that's one way. Now, we're going to today look at how to determine if lines are parallel using the equations of graphs. So, if we look, the two lines we have line 1, which is y is equal to 2x plus 2. Then we have line 2, which is y is equal to 2x minus 1. Now, if you study these two graphs, there is something here that tells you that the lines are parallel. Here, you can see they are parallel. You can use geometry and prove it's parallel. But if you look at it here, then you will find that something here is telling you that the lines are parallel. Well, if you look at the two equations, you will find that these are different, so that doesn't tell you anything. But if you look here and here, you will find that the gradients are the same. You will find the gradients are the same. So, gradients are same. So what do you conclude? So we conclude that parallel lines have same gradients, or parallel line have equal gradients. You can talk like that. I can say parallel lines have same gradients, or I can say parallel lines have equal gradients. So, that gradient and this gradient is the same, or these gradients are equal, therefore these two lines are parallel. So we can conclude line 1 is parallel to line 2. So that's the first thing we want to learn about parallel lines, that parallel lines have the same gradients or parallel lines have equal gradients. Right. Now the next, let's do a little question now. Suppose you are asked, y is equal to 2, let's make it negative 2x. Y is equal to negative 2x and 3x and 6x plus 2y equal to 8 parallel. Now you ask the question, y is equal to minus 2x and 6x plus 2y equal to 8 parallel. Well, we just learned now that if the gradients are the same, they are parallel. Now we can't compare them straight away, so what we do this. We say line 1, y is equal to minus 2x. This is in standard form, so everything is in order for this one. Now if you take line 2 you are told 6x plus 2y is equal to 8. Now this is not in standard form. So before you can talk about parallel lines or perpendicular lines, you must have equations in standard form. This one is in standard form. This one is not in standard form. So I have to bring it to standard form. So 2y is equal to negative 6x. Sorry, this is 3y. This will have to be 3y, sorry. Where's the question? 3y. So that's a question. 6x plus 3y is equal to 8. 6x plus 3y is equal to 8. So here we have 3y is equal to negative 6x plus 8. So now you're going to divide by 3. Divide by 3. Divide by 3. And that will give you y is equal to negative 2x plus 8 over 3. We compare now. We compare. Line 1, the gradient is negative 2. Line 2, the gradient is negative 2. We're only interested in the gradient. The y-intercept can be different. The y-intercept here is 0. The y-intercept here is 8 over 3. That doesn't matter at all. It's only the gradient. So the gradients are the same. So therefore we can say line 1 is parallel to line 2. Alright, so those are the kinds of questions that you can be asked on parallel lines. You can be given these two and asked, are they parallel? They are in standard form, gradients are equal, therefore they are parallel. In this case, are these parallel? Well, number 1 is fine, it's in standard form, just write it down. Number 2 is not in standard form, bring it to standard form. After you bring it to standard form, then compare. When we compare, the gradients are the same, therefore the lines are parallel. Don't worry about the y-intercepts. Y-intercepts can be different. Even here you can see y-intercepts are different. Alright, so that's how we determine lines are parallel or not. Alright, so let me give you a little exercise to determine whether lines are parallel or not.